Okay, this is your first unit notes, and you need to make sure that you take notes in your composition notebook. I will do checks on your composition notebooks and give you grades to make sure that you are taking notes on the notes that I provide for your recordings. Um, First off, when we talk about the scientific method, you've heard this for years coming up, and you've got a systematic approach to being able to solve problems with the scientific method. It really doesn't matter whether you use 5 steps or whether you use 7 steps, as long as you are using a step-by-step method to solve a problem. And in this class, most of your problems are going to be presented to you so that you can, that step's easy, you go from there, try to figure out how to solve that problem or answer the question. Now, first off, like I said, you have an objective, a question that you want to find a solution to. Your hypothesis comes next, and a lot of the times before you were taught that in between the objective or your question and the hypothesis, you're supposed to gather information. That's what this class is for. The information that I am giving you is the information that you're going to be using in order to do your experiments. So your background information is the content of the class. So your hypothesis is an educated guess based on the learning of all of that content, based on that background information. And your experiment is where you test your hypothesis to see if you are right or wrong. Prove yourself true or false. Now, the biggest thing that I want to get into is experimental design. In the experimental design, you've been taught this since probably the 3rd grade, but people still have a hard time with differentiating between independent, dependent variable, understanding what a constant is, what a control group is, and so forth. So one of the main things you need to take away from this is being able to differentiate between those parts of experimental design. So when you set up an experiment to test your hypothesis, you need to set up a controlled experiment so that you have a single variable that is being tested and being studied. Now, when you have that, you have different parts to that variable. You have what the variable is, and you have what it does. So what you're testing is the independent variable, and what happens or how that variable responds is your dependent variable. So like you see to the right side of the post, you've got your independent variable always will influence the change in the dependent variable. So the first thing you have here is that your independent variable is the one that is being manipulated, the one that is being changed by the person doing the experiment. So, like for example, I used to teach this in 6th grade. I starts independent variable, so it is what I do to test. It's what I am testing. It's what I am changing. So the word manipulated means simply to change. So whatever is being changed or tested in the experiment. Now, the dependent variable is what is happening. So that's why we call it the responding variable. The dependent variable, you will see as we go through some of our examples, can be easy if you just sit back and think about it. It is what you write down as a result of your experiment. So if you're doing an experiment testing to see if certain fertilizers are going to make flowers grow taller, well, you're obviously going to put different fertilizers in the plants. That's going to be your independent variable. But when you sit back and see what's happening, that's how the plants are growing. So the height of the plants is your dependent variable. Dependent variables are going to be measurements, both quantitative, which is going to be your number measurements, or qualitative, which is going to be a descriptive measurement. But either of those is basically what happened in this experiment. That's my dependent variable. And again, going back to what the word is saying, my dependent variable is going to depend on the independent variable. And as the independent variable is manipulated, the dependent variable is going to be measured for variation. So measurements, both qualitative and quantitative, are going to be your dependent variables. All right. Now, when we're controlling our experiments, one of the main things, not all experiments have this, but a good experiment has an experimental group and a control group. And it might have more experimental groups. It just depends on what you are testing. But an experimental group is going to be the group that is being tested, the group that gets the independent variable, or whatever you're doing or testing as far as your independent variable goes, that happens in the experimental group. The control group is the other one. It is the group that is being set aside to compare the experimental group to. So if you're looking at the, right here, your cartoon, and it says, well, I guess we're the control group, you can speculate with this cartoon that these two mice are a part of your experimental group, because they obviously got whatever the scientist is testing. These two mice here are a part of the control group, because they did not get what was being tested. The only reason that these two mice are sitting here is to compare their actions to your original two mice. Now, so basically the control group is going to allow the experimenter to have a baseline measurement or to have something to compare their results to. So, again, difference between control group and experimental group. Control is the group that you're using for comparison. You do not give them the independent variable. In other words, you do not test this group. They're not tested. The experimental group is the group that gets the independent variable. This is the group that gets tested. All right? Now, one final thing about your experimental design are constants. So if I say, like the word insinuates, if I say she constantly talks, that means that she talks all the time. So constants are the things that always stay the same in an experiment, and they are very important. Sometimes constants are called controlled variables. I don't really like this because controlled, people get that mixed up with control group, and variables insinuates there's more than one, and there cannot be more than one. But the reason constants are called controlled variables is because those are the things that could change in an experiment, but you do your best to keep them the same. So that what you are testing, the independent variable, is the only thing that makes your results happen or causes your change to happen. Now, this is an experiment that you will do in class, so that you can see this going on and apply these concepts to, but this is all about glow sticks. So it says, imagine you want to do an experiment to test if heat will affect the brightness of a glow stick. So when you are looking at this one statement, you can automatically pick out, what am I testing and what am I testing it for? So what you as the experimenter here are testing is the heat. So the heat is your independent variable. What you're testing it for, the brightness of the glow stick, that is your dependent variable. Keep in mind that's measurable. It's a qualitative measurement because you can visually look at a glow stick and see if it's brighter than another glow stick. All right, so what you would do with testing this, and what you will do, is set up 2 beakers, one cold and one hot water. Break the glow sticks, put one in each of the beakers. Obviously, there are some other things that have to be considered. One being the constants. What do you need to make sure are the same? So think about that for a second. If you were to set up this experiment, what are the things that you would need to make sure that you keep the same in order to determine if the heat makes the glow sticks brighter? Okay, so this is going to answer it for you. What needs to be kept the same between the 2 setups to make sure that the heat is actually what is making the glow sticks brighter? So if we're looking at these 2 setups, and you've got 2 beakers, so you've got beaker A and you've got beaker B. Okay? In those 2 beakers, what you're testing, again, is does heat make a glow stick brighter? So what do we need to be kept the same between these 2 setups? What I would say, number 1, you want to have the same amount of water. So in here, you want the amount of water to be right at the same amount. So you would measure it out, say 50 milliliters of water each. The other thing that you're going to want to make sure is the same is maybe the same beaker. Same size beaker, same type of beaker. So those are the same. Now, when you go to introduce the glow sticks in, one of the things that you want to make sure are the same would be the color of the glow stick. One of the things that could affect your results is you typically have some glow sticks, as you can see in the picture, you have some glow sticks that burn brighter than other glow sticks. So taking into consideration the green versus the orange. Green's brighter anyway. So if you had 2 different colored glow sticks, you couldn't see if the heat made one brighter or not. The other thing is sometimes you can have this type of glow stick where it's kind of a thicker glow stick, and sometimes you can have the really skinny ones. So obviously the thicker ones are going to be a little brighter. So you want to make sure inside that your size of your glow stick is the same. So the size of the glow stick needs to be kept the same between the 2 of them. All right, now you could go on and on and on with these things that need to be kept the same. You could say that the environment that both of these are setting in needs to be the same. You could go on and on with what you should keep the same. That's why they're called controlled variables. These are all things that could affect a change in your results, but you're controlling them between your 2 setups to make sure that they don't affect a change. The only thing that you want to affect the change is your independent variable, which is the heat. And the heat here is in your experimental setup. Okay? So this one gets a certain amount of heat added to it. Okay? This one over here, no heat. That's why it's called the control setup. We want to be able to compare the one that is heated to the one that is not, with all of these things being kept the same. Okay? Dependent variable. In both of these, we're looking for one thing. We are looking to see if the glow stick is going to burn brighter or not. You cannot see what a dependent variable is truly until you've done your experiment. So you guys will actually do this experiment, and you're going to be able to plot what the dependent variable is. But we can kind of get in general what we're looking for. So in general, we're looking to see what the brightness of the glow stick is going to be. Does the heat burn brighter, or does the one that does not have the heat burn brighter? And that is the answer to your question. So you're not going to get this until you've done the experiment, because this, your dependent variable, that's your results of your experiment. Okay? The other thing that I want you to understand is that only one variable can be tested at a time. Like, for example, what I told you, you couldn't have two different glow sticks. You could not have two different color of glow sticks, two different sizes. You couldn't have two different amounts of, like, as far as the water goes, it couldn't be different amounts. Every other variable that could affect a change in that experiment needs to be controlled, and that's why they're called constants. Keep those the same between your setups, between your experimental setup and your control setup. Now, we can put this in like a math equation. So for a math equation, I could say 2 plus blank equals blank. So if whatever your final answer is always going to depend on what you put here. Okay? 2 is always going to be a constant. So let's say that 2 plus 1 equals 2. So the 2 as your final answer is going to depend on the 1 that you put there. This one's a constant. Let's say that you do 2 plus 3. That is going to give you 5. The 5 as your final answer depends on the 3 that you put there. So that's mathematically how constants and variables are used. So if we're looking here scientifically at constants and variables, we have our constants. We have the fact that we have the same beaker in both our setups. We have the same type and color of glow stick. Sorry about that line. We have the same environment. So we're looking at what's the same, or constants. What's the same between our experimental setup and our control. Okay? So our constants plus. So now we're focusing on our experimental setup. Our constants that are in our experimental setup, same beaker, same type and color of glow stick, same environment, is going to, what we add to that, our independent variable, what we're testing, is our heat. Okay? So our heat is our independent variable there. That's what's being tested. And again, dependent variable, that's your final result. We don't know this. We haven't done this experiment before, so you guys are going to be doing this. You will be able to see what the dependent variable is. But for now, we know what we're looking for. We're looking to see how it affects the brightness of the glow stick. So, constants. We have everything that we keep the same between experimental and our control setup, plus the heat is going to be equal to how bright the glow stick is going to be. All right, so some examples. What I want to do, a lot of the times people have a hard time looking and reading an experiment, which is what you have to do on tests typically, and identifying what is being tested, what's my independent variable, what am I testing it for, dependent variable, and what things have to stay the same between our experimental and our control setup. So one of the best ways I can teach you this is to show you pictures. This is, if you're a visual person, pictures are going to be very good for you here. So this says Sarah wants to see if a new brand of hair dye lasts longer than the brand she currently uses. She puts the new hair dye on the left side of her head, the old brand on her right side, and after 2 weeks she observes which side of her head has more gray hair showing through. So what you're looking at first is the fancy drawings here. I have a head with a left side and a right side. It tells me specifically up here that on the left side, she gets the new hair dye. On the right side, she puts the old hair dye. So now we're looking for what our parts of our experiment are. So when you're looking for the independent variable, you want to specifically go back and say, what's she testing? Well, it says it clearly right here. She wants to see if a new brand of hair dye lasts longer. So as an experimenter, Sarah is testing the new brand of hair dye. So this side is going to be your independent variable. This side is actually going to be your experimental setup, and it contains your independent variable, which is the new hair dye. All right. Now, dependent variable. What is she testing it for? What are the results she wants to find? So if you keep reading it, Sarah wants to see if a new brand of hair dye lasts longer. That's the results she's trying to figure out. So basically, time is your measurement. You're measuring how long is this dye going to last. So your dependent variable here is time, and you can continue it with time the dye lasts. Okay, now constants. One of the things that you'll look at here is seeing that this side is your independent variable on the left, and that's your experimental setup. The right is your control setup. So what are the things that are the same between your experimental on the left and your control on the right? What should be kept the same? Now, one thing immediately that you should notice is both sides are getting hair dye. So that has to be one. All right. The other, if you look up there, and you can speculate what else she should keep the same, but we're looking at the same person's head. So the head's the same, and therefore the hair, the type of hair and color of hair is the same. So type and color of hair. And then you have the same amount of time. That the dye is on the hair. Okay, so you can keep going and going with constants. The more that you have, the better your experiment is going to be. Now, keep in mind that this is the only part of the experimental design in which there's more than one. Everything else, there's just one thing as an answer. Okay? Next example here, Chris wants to see if his basil plants grow better in full sunlight or partial sunlight. He plants 5 basil plants on the east side of his house that only receive light in the morning and 5 more on the south side of his house that receive light all day. After a month, he measures the height of each plant. So let's kind of get a visual of what he's doing. We have his house, just a quick sketch. And so let's divide it and say this is the east side and this is the south, because these are the two that we have up there in the scenario. Okay, now specifically what he has in there, he says that each side, the east and the south, both have 5 basil plants. Okay, so he plants 5 basil plants on each side. On the east side of the house, it only receives light in the morning. So on the east side, we're going to put that there's only light in the morning. On the south side of the house, it receives light all day. So this is going to be your full light. And this is going to be your partial. Because if you go back up and look at what she's testing, she wants to see if plants grow better in full sunlight versus partial sunlight. Okay? Now that first sentence is a good example of how your independent variable is not always indicated first in a sentence. Okay, this one kind of turns it around. So you want to say the independent variable is the amount of sunlight. You don't just say sunlight, because both of them have light. You want to say the amount, because that's truly what's different here. So amount of sunlight is going to be your independent variable. That is what Chris, is testing. Okay? Dependent variable, what's he testing it for? So when we go back up and we look, the color. When we go back up and look, he wants to see if his basil plants grow better. Growing better is your measurement here. That is what you're going to set back and evaluate. That's going to be your results. So the growth is your dependent variable. And again, you don't know the answer to this until you have done this experiment. But you can kind of give an idea that this is what you're looking for. That's what that person is looking for. Okay? So you could say growth, you could say height. Both of them are going to insinuate the same thing. All right, so we know that this is, one of them is going to be your control, one of them is going to be your experimental. So for this, I could kind of pick. So I'm going to say that my experimental is the full sunlight. Sorry. Okay, so that's on the south side. My control is going to be the partial. It depends, when you're comparing two things like this, it just depends on what you're trying to see and evaluate. But I labeled those two because I want to see what has to be kept the same between the two. So right off you see that we've got 5 basil plants on each side. So they have to be kept the same. You've got them both in the same house. So if they're both in the same house, there's a lot of things that fall under that. The environment's the same, the temperature's the same, and so forth. You have both of them having some light. So light is the same in both. Don't confuse that with this, because they're testing amount of light. Okay? So independent variable, he's testing the amount of sunlight. Dependent variable, he's testing it to see how it affects plant growth. So independent variable influences your dependent variable, and things he has to keep the same, the constants, are going to be what's listed here. And again, you could have a lot more than this. All right, one last slide here, and this is where I'm going to get you guys to come in with this on the next day. Come in with your answers to this. This does not have a paragraph, but I do have to give a little bit of the background information. It says, does increasing the surface area of an Alka-Seltzer tablet make it react faster with water? So a little bit about surface area if you don't know. Surface area is how much contact the particles have with the outside environment. So if you're looking at something like this, think about it this way. Just these particles that are on the surface of that cube, let's say it's a sugar cube, only the surface ones that are right here have contact with the outside environment. If you were to take that cube and break it up, then all of these, if you look at the yellow lines, now all of those molecules on the surface of each of those have exposure to the outside environment, and so on. Break it up even more, and even more have exposure to the outside environment. So if this is an Alka-Seltzer tablet and it's whole, then you only have the surrounding molecules that have access to the outside environment. However, if you take that tablet and you break it in half, then you've got more molecules that are exposed to the outside environment. And if you take that tablet and you break it into fourths, sorry for the line, you've got more molecules that are exposed to the outside environment. So from this point on, you are increasing the surface area. So what I want you to do is evaluate really quick if you were doing this experiment. What is your independent variable? What is the dependent variable? And list at least 3 constants you should have. And that's it for your first lesson. Make sure you come in with notes. Make sure you come in with answers to this.